Hi, today we're going to be talking about section 2.5, which is linear functions and models. The slope and the equation of a line. We don't have a video for the slope and the equation of a line, but what is slope? We did mention in class what the slope is. We said that the slope is a measurement of how steep your line is. And it is important because you see it all the time. Sometimes you guys have seen it like on the mountains, and we call it sometimes like they call it the gradient. And also sometimes when you're driving, you have seen some sort of a sign with a triangle in it, and then it says maybe like a 10% incline, or it has like a careful symbol. And the reason why you gotta be careful, it's because it's measuring how steep your line is, and you just have to be careful when you're driving in that area. This doesn't look like a 10%, but sometimes you have seen it that way. Okay, the calculation to find the slope of the line is this one, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the one that all of you guys have seen. And then this is the one that we said it's called the change in y over the change in x. And we also call it the rise over the run. And it has a lot of names. Like in section 2.4, we call it the difference quotient and also the average rate of change. Okay, where x1 comma y1 and x2 comma y2 are 2 points on the line, and n represents the slope. Go ahead and find the slope of the line passing through the following 2 points. Okay, so if we have a picture like the one you see here, we're only measuring how steep your line is. We have 2 given points on the graph, and then from there we can actually calculate the slope. So I'm going to start here. This is going to be m. I'm going to call it x1 here and y1, and then I'm going to call it x2 and y2. And so then my formula says y2. Y2, it's a -2. Then formula has a minus. Then y1 has a 4. And then we have an x2. And x2 is a -4. Then minus. Then an x1. x1, it's a -3. And then using a calculator, you can plug it in. -2 minus 4, it's a -6. Over, well, 2 negatives become a positive. -4 plus 3, it's a -1. And so then the slope happens to be 6. That's it. That's how you do it when you have 2 points. Identify the slope of each line. Okay, what we want to know is what type of a slope do we have? Do we have a positive slope? Do we have a negative slope? What type of a slope do we have? Well, in this particular case, on example number 1, if I draw 2 different points on the line, let me just use those 2 points right here, then I can see that I'm going to, rise and run. My slope in this case is going to be positive. It's like I'm gonna go up right here. This line has a positive slope. What about the second one? Well, the second one, if I have 2 points also on the line, then I can see that I'm going to drop. I'm no longer going to rise, but I'm going to go down, and then to the right. So in this case, my slope happens to be negative. And so my slope is coming this way, my line. Okay, now this next line, I can see that my line it's constant, like it's not really moving. This line is just like this, it's not really moving. There's really nothing happening to it. And so in this case, my slope, it's not changing. My slope is 0. I am not moving anywhere, I'm just here. And then last, well, if I wanna rise, think of you trying to climb the wall. You are not able to climb the wall, neither am I. So then our slope in this case, it's undefined. We don't have one, it's undefined. A linear function is a function of the form f of x is equal to ax plus b. The graph of a linear function is a line with slope a and y-intercept b. Okay, sometimes in this textbook, they decided to change the notation, but I'm sure many of you guys have seen y equals mx plus b. And you can see that it's the same formula, just instead of the a, we have an m, or instead of an m, we have an a, and then we have the same b. Okay, so in terms of what I'm trying to say right here, I'm going to give you a small picture. And if I give you a line, this point that you see right here, it's what we call your y-intercept. And this y-intercept, it's the order pair 0, comma b. This b that you see here, it's the b in your formula, okay? So it's always 0 and b. Okay, that's all I need to know from here. Use the graph on the right and find A and y-intercept B, then write the linear equation. Okay, so the linear equation, it's y equals mx plus b, or y is equal to ax plus b. Okay, so in this particular case, I can see which one's my y-intercept. Okay, I can find the point. The point is 0, comma, -2. With that, I know that b is equal to -2. And then I know I can find the slope, which is a, it's the rise over the run. How many times do I go up? And then how many times do I run? So then I can see that I kind of go to the right 3 units. This length here is 3 units. And this length here is 2 units. So it's 2 over 3. That's the rise over the run. In this case, the line's going in this direction, so I know that it will be positive. Okay, what's the equation? Y equals, I'm just going to plug in what I have. A is 2/3 x, then b. B is -2, and this is my equation. That's it. Go ahead and graph the linear function using the linear function. F of x is equal to x plus b. Okay, so in this particular case, it's already given in that form. F of x is equal to ax plus b. One more time, or mx plus b. My slope happens to be the -2/3. And then my y-intercept happens to be this number right here, which is the 2. As an order pair, I'm going to write it down as 0, comma 2. Okay, let me go ahead and graph it. Okay, I have 0, comma 2. It's here. That's my y-intercept. Then from the y-intercept, so this one goes first, I'm going to apply the slope. But because the slope is negative, we're going to go down 2 and then to the right. If the slope is positive, we go up and then to the right. Okay, so down 2. So from here, I go down 1 and 2, and then to the right 3. 1, 2, and 3. Here's the other point. I'm going to connect them. I can do as many points as I want to from just the next point. So if I wanted it to find another point, I can just go from here. I go down 2, then to the right 3. 1, 2, and 3. So my other point will be here. And so you can see that every time we're kind of drawing a triangle. Okay, in this case, my slope it's negative because my line is going in the negative direction. Determine which represents linear and which are not. Okay. In order for you to have a linear function, your exponent or the variable has to be degree 1. Okay, so in this case, the degree is 1 and the degree is 1, so this is linear. Okay, the second one, this is degree 1, but this one's in the denominator. That when you move it to the numerator, that's going to be 2x to the negative 1 minus y equal to 5. This here, it's no longer linear. So this one's not linear. Okay, I move on to the last one, and then I check their exponents. That's exponent 1, that's exponent 1. Yes, linear. Okay, I'm gonna move on to the slope and rate of change. Adam is built on a river to create a reservoir. I'm sorry, a dam. I said Adam. A dam is built on a river to create a reservoir. The water level F of t in the reservoir at time t is given by this formula, where t is the number of years since the dam was constructed and F of t it's measuring in feet. What is the slope? Okay, they have given you a formula. This formula, when I compare it, I can see that this formula, 4.5t plus 28, if I compare it to what was given before, this is, let me go ahead and, this is f of x, it's equal to ax plus b. I can see that the slope happens to be a, so then the slope happens to be 4.5. The slope is just 4.5. At what rate is the water level in the reservoir changing? At what rate? The key word is rate, but at what rate means we're talking about the slope also from section 2.4. So it's also 4.5, but now you gotta include the units. So in this case, the units are feet per what? Per year. This is what makes it a rate. Now I'm actually telling you this is 4.5 feet per year. So it is changing 4.5 feet per year. Okay, that's how much it's changing. Okay, let me go ahead and move on to the last problem for section 2.5. It's problem number 41. Weather balloons are filled with hydrogen and released at various sites to measure and transmit data about conditions such as air pressure and temperature. A weather balloon is filled with hydrogen at a rate of 0.5 feet cubed per second. Initially, the balloon contains 2 feet cubed of hydrogen. Part A, can you find a linear function V that models the volume of the hydrogen in the balloon at time t? Okay, you might have to read it on your own once again. So if you need to, you can pause the video and read it if I am reading it too fast for you. Okay, so they're asking me for several things, but they want me to find a linear function, and they want me to write it down in terms of V. Okay, so that's what I want. Now, V stands for the volume. I know it's the volume because they told me here. And then the time the T has to be the time. And then I need the A, the slope, because remember, I gotta put it into the form f of x, it's equal to ax plus b. I need to find A, and then I need to find B. What's A and what's B? Okay, if I keep on reading it, it says right here, a weather balloon is filled with hydrogen at a rate. There's the keyword. The keyword is the word rate. The rate stands for the slope. So in this case, the slope is 0.5. Now, initially the balloon contains 2 feet cube of hydrogen. That's your V. Okay, I am ready to put it into that form. So it will be V of T. It's equal to 0.5 T plus 2. That's it. Part B. If the balloon has a capacity of 15 feet cubed, how long does it take to completely fill the balloon? If the balloon has a capacity of 15 feet cubed, how long does it take to completely fill the balloon? Okay. How long? The keyword is here. How long does it take? How long does it take? That means that we are looking for the time. That's what they're asking. So then that means that 15 has to be the V, because I'm going to plug it into this formula. So this will be 15. It's equal to 0.5 T plus 2. I'm going to solve for T. So then I'm going to subtract 2. That gives me a 13. I get 13 is equal to 0.5 T. I'm going to divide both sides by 0.5. When I do 13 divided by 0.5 gives me 26. 26 is equal to T. So T is equal to 26. Now 26 what? I gotta make sure I pay attention to the units. In this case, the units were, if you go back to the word problem, I'm gonna highlight it in blue so you guys can see the units are here. So the units were in feet and in seconds. This is the time. So then T is equal to 26 seconds. How long does it take to completely fill the balloon? It will take 26 seconds to completely fill the balloon. And then that's it. Okay, we are done with section 2.5. I hope you guys can do the homework. If you guys have any questions, let me know. Have a great day. Bye.